Right, I'm Tierna and this is Neve, and this is our program. We made a canvas game using Cordova.
We put the canvas inside a div. A div tag.
We put the canvas inside a div. We have a canvas inside a div, and it's written to by Cordova. And from here, you can see once the device is ready, after we've loaded our images, and we have a few variables in place that we're going to use later. Device ready. We hide the message that's hidden behind it. We attach a canvas. We fetch the div that says that is called game canvas. That is a canvas ID. Pass into canvas, and then we
set the canvas width and height.
And then we apply dot context to the canvas and pass it into G. G is what we're going to use to draw everything as we go on.
And then we get the center using X and Y. So we have the center of the canvas.
Right.
And that's where we start our player. When we first generate our player.
First thing we do is we start our main menu. After that, and this opens up a
swipe
menu.
Yeah.
The first thing that happens is a start menu is drawn. Some debugging code from earlier. And we declare some variables, and then
we find the start that you touch and the end that you touch.
Yeah, so we have a wee image called start, and what we do is we run 3 event listeners. One to check for the start of a touch, one for movement, and one for an end touch. And what we do is we take the X and Y position of when we first touch the screen, and then the X and Y position of when we're last touching the screen, which would be the last touch move that we receive before we reach touch end, which would be the finger off the screen. And all that. Happy jazz. From there, we check using was swiped and using the values that were passed into touch and start X, touch start X and touch end X, and we find out if it's swiped right, if it's swiped left, or
if it was not swiped.
Or if it was not swiped at all.
Then it gives you menu option equal to 1.
Yeah, when
and it starts it.
Yeah, when these menu options. This is the actual selection. This would be the touch, the tap, and these 2 parts of this image would be the swipe. And as you can see, you call previous image and next image.
So we'll go to next image. So that's just drawing the image.
Yeah, so this part we check what option the menu has. Similar as we did before, we check what option the menu has, but this time here we were executing whatever we wanted depending on what button it was. Here we're changing the button depending on where we are, because we want to be able to move cohesively through a menu. Let's say we have start, menu, and quit. Then, as you see here, we don't want to swipe to the right, go to the next thing in the menu and see that we've gone from the start to the quit. We want them to move in an order, and so we have obtained an order by using these if statements. And then inside of that we clear the background, draw the image, and change the position, which is stored in that. Same for previous image, but it's backwards. Back up here. When you start the game, you call start accelerometer watch.
This calls a function that will check the acceleration every 20 seconds. And then it calls on acceleration success or on acceleration error. So go to this one. This it first you set the X and Y position, and then you check. Yeah, and then you determine where the player position is, and if the player's X or Y position is hitting the rock that we we drew on the canvas earlier, it deducts the score and it sends a vibration to the phone. And then we put in a coin. So
vibration would be one of our extra functionalities that we have. Also, our collision detection. This is something I took from another project of mine, as in this logic, and it's simple. It's basically right.
And then we do the same thing for coin. Check if the player is within the sprite, and then it's going to add to the score. And then if the score is less than 5, it's going to keep rendering the canvas, and if it's equal to 5, then it runs the win animation, and that's you've won the game if you get 5 coins. So
you render canvas or right. Let's talk about render canvas itself.
Like Control F.
You don't need to.
So when the count is set to 0 first, so that will allow you to render the background, render the player, and render coin, and render rock, and we set them into different functions to make the code neater. And
so that we can call render coin at any point if we wanted to add a new coin.
Yep. So
and then we'd keep drawing coin.
So if it's
and it would draw all the coins.
Yeah. So this is the first if statement is basically the first run, and then the else if is the next runs.
Right. So yeah, since the first one it renders everything, and this one it renders the background and then draws everything on top of it. Render would create a new thing. Alright, we have a few functions here that clear things out.
Didn't talk about this.
Oh, vibrate. Yeah, vibrate was just a simple, very, very simple line of code.
So it checks if it's vibrating, and if you've hit the thing, and then it will send you to vibrate. So if you hit the rock, it will vibrate, or if you hit the side of the screen and try to go outside the canvas.
Yeah, or if you hit a rock, it was the collision I showed earlier. This here. If you collided with a rock, you vibrate. And I'm not sure where else it's called.
It's called if you try leave the canvas. So that's the player's position.
It's 4 places. If you touch the border of the canvas.
And also it will redirect you back inside the canvas.
It won't let you move any further.
Yeah.
In fact, it's like... alright.
Just pause.
Alright, so next on the agenda. We have this thing.
So, let me see. So, for spin, we determined what way the player is moving on the X and Y position to determine whether you are moving clockwise or anti-clockwise.
They would take. You have 2 different values for X, and since the accelerometer, since the velocity, the acceleration is so precise, you very easily be able to tell if you're speeding up or slowing down, even if it's only by a small amount. So it would instantly put you towards spinning in a certain direction. And as we can see here, you've got your different spin directions and they get passed in. But what really matters is the maths that comes after. And here we have...
Depending on how fast the head image is moving, it will spin more. So these 2 lines of code are used to make it more realistic and to basically get an accurate calculation of where the X and Y position is from the old X and Y position.
Cool.